Hello, good morning and good afternoon, everyone. I'm Cesare Pautasso, and I'm going to show you a little bit more behind-the-scenes look into how we came up with the patterns that you can read about in the Patterns for API Design book. And one way to find patterns is actually to look for them and to visualize the objects that can contain them. So in this talk, I'm going to show you many visualizations of APIs, and we will try to see if you can spot some of the patterns. What I will present you is many examples, many APIs, and we are going to look for the two main patterns that we can use in an API. Either use the API as a processing resource, as a way for clients to delegate some computation to the API, or as an information holder, as a place for clients to store information. And we're going to look at a data set that was published as being the first large collection of APIs on the web. And the blog post announcing it mentioned more than 100K artifacts. In particular, we're talking about OpenAPI specifications. When we downloaded the Tarball, we found a little bit less, and then when we went through the OpenAPI validation tool, then it was even a bit less, but still is a substantial number that can help us to spot some of those patterns. So if we take an even smaller sample of about 1,000 APIs, this is how they could be visualized all of together. So what we are doing here is measuring the amount of HTTP methods that are present in the API that clients can actually use to call the various operations. And if we zoom in a little bit, we can see single APIs and how many of those methods are present. The largest API that we have in the collection is actually more than 3,000 methods. So this is a huge API, and most of them are actually below 1,000. And then if we scroll a little bit to the right side, we go into 500, and then of course if you keep going, then you will find a tiny little micro API of few tens of operations. But this is just to give you an idea of the kind of APIs that people have built and described, and then you can find out there. Now, if you want to look for patterns, you have to have a way to classify and to group these APIs together. So one thing that you can do is measure the size of the API, not in terms of how many operations it has, but as many endpoints. So that will be the little black marker that you can see. And if you do that, then of course you can sort by the number of paths, and then you notice something. There are some APIs which use exactly one operation per path. So every path has a different HTTP method, and other APIs which have more. And those are the ones that are actually sticking out of the black line. Now, if you filter, then you have immediately two different collections. The one that have multiple methods per path, which is closer than 40,000. Including the largest ones, of course, because they have more than one method per path. Or you could actually look for the ones in which the designers of the API have selected a single method, and the methods are colored, as you can see. And then these are a bit less, but they're still interesting on their own. Now, if you then look for which kind of method is the more prevalent in this case, then you can see that the yellow color, meaning the post method, and the green color representing the get method are the most frequently used, while the put and delete, the other operations that you can do using HTTP, are a little bit less frequently found, and those APIs are the ones that are actually sticking out in this visualization. You can further cluster and subdivide the collection depending on which method combination are actually present. So not all API designers make use of the full expressive power of HTTP. In some cases, they use a subset of the methods. So in this case, if we only look for APIs that read, write, or delete, then you have only these three colors represented. then we can see a group of APIs in which they use exactly one method per path, and then on the other side we find APIs that use a combination of methods per path. And you can see the set of APIs that remains is smaller and smaller. We can do the same with APIs that can read, write, and update using put, and it's a similar size collection, which is this join. We can also just look for the read-write APIs. These are the ones that have read and post, get and post. And we keep going. We can just get the ones that use only post, which is about 4,000 of those. And then there is actually more that only use get. These are OData, APIs that are used for reading, and no other state changes is supported. We can also look for APIs that never use post. There is actually quite a few of those, which is was kind of interesting for me. And also the opposite, APIs that don't read. For some reason, there are actually quite a few that only support post, and a few other method combinations, not too many. If we actually remove the most frequent methods that are present in an API, get or post, then we actually have a very tiny little set of APIs that are super small. They have just one operation. So these, I wouldn't, how do you say? It's such a small sample that I wouldn't draw any conclusions in terms of these being a pattern or not, because there are not so many designers that actually do that. And then we can do the same again. We can have APIs without put. Here we have a few patch that stand out, which is a more frequent, recent introduced method, so not so used, but in some cases it is. And then eventually we can also look for the APIs that sometimes are also called as CRUD, the ones that do create, read, update, and delete using get, post, put, and delete. So this will be visualization of those, and there's quite a few of those actually. Are there APIs that make full use of all the HTTP methods, including head and trace? Yes, and it's quite a big sample. Actually more than the ones that only use post or only use get. So if we take an overview about all of these groups of APIs, then we can try to visualize it to sort of get a feeling for how prevalent are these colors in the APIs, how prevalent is the use of these different method combinations. And this picture will show you that. But pie charts are a little bit misleading, so I'm going to make them a little bit more proportional to the actual amount of methods, and then we can really see that the most frequent type of method used on the web is get, so read-only APIs, and then there is the post, and then the rest is really there, but it's not so frequent at all by orders of magnitude. So that was the first message, right? So if somebody asks you what is the color of your API, then you can look at the methods and see what combinations are present, and then you can try to fit your API in one of these groups. And depending on which methods you use, you will have different properties. Whether the API, for example, is read-only, whether you do read and write, whether you have full CRUD expressive power, or any combination of the above. Now, when you look for patterns, it's also interesting to look at the individual APIs. So not just as a whole collection of thousands of APIs grouped together because they're somehow similar to each other, but we're also interested to look at individual APIs. So to do that, still looking at the endpoint structure, at the methods that are present, we can have a way to have a fingerprint of an API, like in this visualization, or we can try to look at the structure of the endpoints and draw something that looks like this. So of course, if you have a single endpoint and a single operation, then you just say, okay, this is a get operation on the hello resource. If you have a set of resources with also in this case only get operations, then you can visualize the structure of the API. And this structure can become quite complex. People, even if the API is only used for reading information, there is, depending on what you read, depending if you can search, you can filter, there can be quite interesting structures to be found there. This is an even larger one with more than 300 operations, so it's still a tree structure, but we use a different layout to show the elements. Now we can also have APIs that make use of post. So in this example, most of the endpoints are related for reading information, but then we can also find one operation, one endpoint that is used for initializing something. So that's post as opposed to, because it affects the state of the API. In this example, we have a mix. So depending on what you're trying to do, you can use some post or some get. This is a very large structure with more 300 operations, and we can clearly see that the use of the method is divided in different parts of the API. This is more where the post requests go, with the exception of a few, and below we have the read-only part. This is something that you find very often when OpenAPI is used to describe not just an API, but an API including a website. So the green part is the website, and the yellow part is the API. So this is, if you have only post in the API, then you could imagine that this post is used to make remote procedure calls into the system. And for example, in this one, it's kind of interesting that they have all kinds of endpoints named as the name of the procedure that you call, including things that are named with get. But they reserve the use of get for doing the watchdog, right? Where they say, I want to get the health check, and if everything works okay, then I can start doing post to actually do the rest of the work. This is a similar structure where there is only post. So this is quite a large collection of RPC, but it's interesting that it's not a flat list of procedures. They actually group them together. So you try to find some structure that groups related procedures together. You might wonder, how is this, is this related to some bounded context analysis? Is this related to some microservice decomposition behind the API? That could be interesting to study. Now, there is one particular type of API in which the method is associated with an English verb. There is some kind of resource, so in this case we have containers, then we have some identifier, and what we can do is we can do a touch, we can change, we can copy, we can execute. So all of these are basic actions that you can perform on the resource, and there is this constraint that the designers have decided what is the most appropriate HTTP method to use when invoking this operation. So I would argue that this was one particular implementation of the pattern that we call the processing resource. A processing resource is needed when the client is relying on the API to perform some processing, some action. So the client comes, it calls the API works, and then it gets back the result. To identify the action that you want to perform, you have a little problem. You have English, in which there are hundreds of different verbs, and you have HTTP, which only has 8. So this is one of the grand problems of API design, using HTTP as a protocol. How do you go from the action that you want to do to the verb that should somehow be used in the API? So it's sometimes people get criticized for picking the wrong HTTP verb because the action somehow doesn't fit. But it's very interesting to observe this empirically and go and look for all the APIs in which you have an action, and this is implemented by an HTTP verb, and see whether people agree. Are there some verbs in English that everybody agrees that they should be mapped to a specific verb? So we try to analyze that, and the result is that out of all the data set of APIs, the most frequent action is list, followed by update, delete, add, search, all the way down. And it's interesting that there is no agreement, though there is no single action for which the verb is used consistently. So there is still some APIs in which the color is different, even for verbs that should be clear, like for example, delete. Delete, yes, that's when delete has the most use of HTTP delete, but in many other cases, even get is used in some cases, right? So you might wonder if this is a mistake, or there is some kind of reason for doing it that way. But it's kind of interesting. Also for example, edit seems put is actually quite frequent, used in conjunction with editing. Updating, put is also frequent, but is not the most frequent. Yeah? So if we look at the verb that is most frequently used in conjunction with a read operation, a get operation, then we find the listing, searching, counting, getting, downloading. So this somehow is reasonable. Right? That seems to fit the semantics, but it's not always the case. So this is sorted by post. So the most frequently action used in conjunction with a post would be adding, which makes sense. Right? You want to create, you want to update, but update is also where the put is actually present. So that was first analysis, trying to map actions of processing resources into HTTP. We also did it on a different level. So sometimes the action is in the context of a certain object, of a certain type of object. So here in this example, you can see I want to add a bookmark. I want to reset a password. So there is two levels in the endpoint. We have an action on a certain object. So if you do that, does it improve? Do you get more clarity? And in that case, we list the action still vertically, and horizontally you can see the objects. And so we have the objects horizontally, and we have the actions vertically. And we can see that it's still a bit of a mess. Yeah? So there is still no clear correlation on saying this combination of object and action is univocally associated with the verb. Even if you look for this easy example like remove, yes, people use delete, but they also use all the other colors. When you're counting certain objects, then there is a green, so a limited set of uniform methods. But it was interesting to study if this translation between English and HTTP can be somehow automated, and the data doesn't give you a clear-cut answer. Now, the other important pattern that I wanted to mention is the information holder. So in this case, I'm interested to see how it's possible to use an API to not process something, but store information. So we have a client that asks the API, can you please hold information for me? And on the other side, later on, you can pick it out, or another client can come by and find it in the API. So that's another very important core functionality on API. So how do APIs express this? There's many ways, and one very common pattern is to use a collection. So in this case, you have an entity, a user, and then nested inside, you have an identifier that tells you which user are you talking about. And then you can have, for example, the ability to enumerate the users, to create users, to get details about the user, to update individual users, or to delete them. And these sort of the basic actions that you can perform on an entity in a collection, or you can perform on the whole collection. If you can imagine, this structure can have many variants as a pattern, right? You don't have necessarily to be able to delete the users. You don't have necessarily the ability to create them. You can do less. So there are many APIs which do not support all of these methods. Now, to study how people have been using this pattern, we have a simple visualization that shows this is equivalent to that, right? On the outer circle, you have the methods on the users, on the entity and the inner black colors are the methods on the individual object that you store in the collection. So if you do that, then you can see what's the design space for storing. Okay, that's an example where we have it. That's another example where it's used a lot. And the idea is that you have all these combinations that are possible. So as a designer of an API, you need to make a decision which are the appropriate method to use when I want to have an information holder you implement it using HTTP. So if you combine these two elements, then you end up with the one that we started from in the middle. But in one extreme, you could have a read-only collection where you just have a read on the collection and read on the item, and you can have a very powerful collection which can do everything on everything. This one will be a collection which you can list, and then on the items you can do everything. So overall, we have all of these combinations, And as a designer, you would understand that, okay, which one do you pick, right? Such a big design space. What are you going to do? So we look at the actual data and see which ones as patterns are actually present. So in this case, is actually very interesting to notice that some combinations are never used. Some combinations are very infrequently used. That would be the blue ones. And then the ones that are painted in white are the ones that are really used a lot in a lot of APIs. And if we resort and reshuffle them a little bit, we push the frequent patterns to the left, then we notice the top type of information holder is actually this one, which is the read-only collection. In the book, we have a special name for that. And so, for example, you have the list of the customers, and all you can do is get the list and get the individual items. So there are many other variants, but because I'm running out of time, I will not go into them. Okay, so I also wanted to talk about API evolution, but I think I will skip through that. The only two interesting patterns, very briefly, are the fact that you need to identify the version of the APIs that you're working with, so that clients themselves can tell you which version do they need when they call the API, and then you can check whether there is a matching assumption. And so the question is, what kind of version identifiers people use out there? So of course, version identifiers are changed as APIs grow, so it's very interesting to study how people decide to make those changes. And from here, you can sort of see that the most frequent is 1.0. Okay, so that's good. But it also stands out that in some cases, you're actually using dates. So there is a very popular cloud service provider that uses dates to mark when they release an API. And this way, you can sort of make a client that depends on an API, and then you can see how the API is aging, right? You have this API from 3 years ago, it's still there, so you know, as opposed to using a semantic version identifier or something like that. Now, these are versions that are taken from the metadata, from the info version of the OpenAPI spec. These are ones that are found into the client requests, into the endpoint. What is also interesting is that some of those are actually parametric. So the clients can dynamically choose which version they want to use, which is a new trend that is coming out. Okay, I will skip this part. Then also go to the last question for the presentation, because in the book we had a big discussion on how to name this pattern. I don't know if you still remember, right? We said, is it 2 in production or is it n in production? And of course, 2 in production 1, because it's empirically known that most of the APIs are there, like 1,000, 1,100 of the ones in this data set are actually with 2 versions. There is actually, however, some that have 14 versions, which, if you think about the release process of a normal software package that you put in a repository, it's not surprising. You publish a package, you keep hundreds of versions. But for an API to support 14 versions, that's quite impressive. So I feel validated that we chose the right name, because 2 in production is indeed the most common pattern. But there are cases in which you have 3, you have 4, up to more. Okay, before I conclude, I just wanted to mention that you can look at your own APIs. There is a tool called OIS3. It's a Visual Studio Code extension that you can install and then use to visualize your own specifications. You'll be amazed what you can discover by looking at an API as opposed to having to read through the code to actually see how your design looks like. And hopefully you will find some of the patterns that I have mentioned. So thanks a lot to Olaf, Daniel, Uwe, and Mirko for working together the past 6 years to complete this wonderful book on API design patterns, and I hope all of you are going to read it and learn something from it in the same way that I've been learning a lot just by being here with all of you today. It was very interesting to be there. So thank you very much, and if you have some questions, I'll be happy to take them.
Thank you very much, Cesare. Actually, the most asked question, you partly answered it already at the very end because, of course, the tooling.
Yes.
Tell us about the tooling. So can you quickly add a couple of more sentences, like who built the tooling and...
Yes, the tooling was built by the students mentioned here, and particularly Suhelia. And the tooling at the moment does the tree visualization for relatively small APIs. When you have large APIs, then we also have tooling to do that, but we haven't released it yet because if there is interested, then we definitely talk to us if you want. If you have large APIs in your collection, we are particularly interested to study them. Mm-hmm. But you will find it on the Visual Studio Marketplace. And also there is an online version.
Yeah. Okay, thank you. And maybe some future work for the students. Thomas asks, do you have ideas or suggestions about doing something similar with GraphQL API, considering it doesn't utilize the HTTP verbs?
Yeah, definitely. Those are characterized by their data model, most of it, and by the queries that the people send. But to study those, we need to have a JSON schema or some way to represent the data model, and also to have some logs about what kind of queries are coming, because those are not described in any static document. So what we are presenting today is static analysis based on descriptions. Of course, if you have the logs, if you know how the APIs are used, then you could do much more interesting things. But usually, people are very sensitive to sharing logs with academic researchers for some reason.
Yeah. Okay, and the last question is not really a question, it's actually a compliment. Ton from the Netherlands, he wrote that in the Dutch energy sector, we are reading this great book and applying the patterns and adopting the pattern language, and he compliments you and your co-authors.
Oh, thank you very much, I appreciate it.